In the previous video, we understood the definition of a relation, correct? And different ways of representing a relation. Now let's try to understand, see, when you know what is a relation, how we use this relation and what is there in a relation between the two sets. This part is quite important to understand. Okay, now let's discuss this over an example. Fair enough? So let's take one simple example. Suppose say we have set A. Now set A, suppose let's say this is 4, say 9, 16. Just 3 numbers are there. Okay. And say we have set B, which has plus or minus 1, plus or minus 2, plus or minus 3. Fair enough? Plus or minus 1, plus or minus 2, plus or minus 3. Suppose if I define a relation where my relation R is equal to x comma y such that x is equal to y square and x belongs to A and y belongs to B. Suppose say this is my relation. Okay, this is the set, this is the relation. Now, how do we represent it? See, this method, whatever I have written, it's the set builder form, correct? Anyway, roster form is there, but most important of all the forms is the arrow representation, the visual representation of the relation between the two sets. Fair enough? Now, for that, what we do first, so we are going to take one particular set here and we are going to take one more set here. So, we'll take two sets. So, here, this is set A, this is set B. Fair enough? Now, we have the values. So, we have 4, 9, 16. 3 numbers or 3 elements in a set. The next one is you have minus 3, minus 2, minus 1, 1, 2 and 3. Now what is the relation here? See, the relation is x is equal to y square. Correct? Or we can also write root of x is equal to y. Anyway, whenever we type, if you do the relation, 4 corresponds to 1 is minus 2, 1 more is going to be 2. 2 values are there. Correct? The next one, for 9, you have minus 3 as well as 3. So we have 2 values. Do we have any value for 16? No, we don't. Isn't it? That means here, very important thing what we have is, those two sets are there, right? A and B. Now what we have a relation between A and B. The relation is R. Isn't it? Now A, what you have, this part is what we call as the domain. The set of elements which is there in set A, that belongs to the domain set. Okay, that is a very important word, domain. Then from A, there is a relation to B, correct? That means B is called as the range, or sometimes it's also called as codomain. So range or codomain. So domain is what? Domain, it is the set of elements where you're trying to find a relation between that and another set. Correct? The elements which belong to that particular set is called the domain set. And once you have the relation, once you get the relation, we get the codomain, or it's also called as the range of that particular relation. Fair enough? So we have domain, codomain, or you can say domain and range. Very important. Now, for each particular element in the domain, you have some particular element on the range, correct? I mean, not everything, but selected one. That means here, for number 4, there are 2 elements which are corresponding to it in the codomain set, isn't it? So for 4, we have minus 2 as well as 2, correct? So those are what we call as the image of the element in the codomain set. Let me repeat it one more time. Here in the domain set, you have number 4. Now for number 4, what are the elements related to it? According to the condition whatever we have, the two elements are -2 and +2. Correct? So 4 is related to these two. That means for the element in the domain, in our example it's 4, for the element in the domain, there is an image in the range set. So this is what we mean by the element and the image of the element. That means here, if 4, so what we say, if the element is 4, then the image of that particular element is -2 and +2, because they are related to one another. Whenever you have a relation, you have an element and you have the image of the element. Now here this is the visual representation, correct? What if I give you the problem in the set builder form? Even then also you will be able to figure out which is the element and which is the image, which is the domain, which is the range, everything. Okay, so what we'll do, we'll take the same example and I'll explain with the help of the set builder form how it can be, how you can notice it. See, what is the what is the set builder form for this one? So we have a relation R. It is x comma y such that we have x is equal to y square and x belongs to A, y belongs to B. My first thing what you guys have to understand is that x comma y is an ordered pair. So since we are looking at an ordered pair, the x value is going to be the first element, y value is the second element. In the sense, x is going to be the domain and y is going to be the range. Or in other words, x belongs to domain. We can write that way also. X belongs to domain and y belongs to range. Fair enough? So we understood which element belongs to domain and range, which we can further confirm this by looking at this one. Domain, this is going to be the range. So this is the domain, this is the range. Now for that particular element, we have a particular image, right? That is given by this x comma y. So for the element x, y is the image. Clear? So for every relation, we have domain and codomain, and for every element in the domain, we are going to have one image in the range. Fair enough? So when I say every element in the domain which satisfies the condition or which satisfies the relation, don't assume that, oh, you know what, the 16, it doesn't have any image. Not like that. What satisfies the condition. Clear? Now, how do we know how many relations are there between the two given sets? Very simple. Suppose if you look at that, remember when you have, suppose say n of A is equal to P, assume, then n of B is equal to Q, then n of A cross B is equal to P into Q. If you remember, we did this in the last video. So n of A into B or A cross B is equal to P into Q. Now this gives us the number of Cartesian products between the two given sets, correct? Number of Cartesian products. Now the total number of relations between the two given sets is given by 2 to the power of PQ. This gives you the total number of relations. This gives the relation, or you can say this gives us the total number of relations between the two sets. Fair enough? So since we have understood what is what in a relation, let's solve few basic problems in the next video.